Good morning, good afternoon, and good evening to all of you. Hope you are all doing well. Today, let us have a knowledge sharing session on a very latest technology, a very cutting edge technology called RAG, Retrieval Augmented Generation Architecture. So, before we dive into the architecture diagram, we will see why RAG. What is the necessity of having RAG? For this question, let us see one of the examples in LLM. Okay, now let me give openai.com and we will open the chat GPT here. Yeah, now look at here. It's a chat GPT 4.0 mini. This is the latest LLM. So we are going to give you a very simple question. Who won the gold medal in swimming at the 2024 Olympics? A simple question. Let us, okay. Now, see, it says, I am unable to provide real-time updates or current event results, including the 2024 Olympics. You might want to check the latest sports news or the official Olympics website for the most accurate information. That means the 4.0 mini, the model does not have the latest information. So the model is not trained on the latest information. That is why I'm not able to get the latest information. So this is one of the major drawbacks of the LLMs. Let us take another example. Let us consider that we are working on a research project in public health. We want to obtain reliable information on disease prevention, including sensitive data. The question is, can we rely on the LLM alone? No, not definitely, because it is giving unreliable data. It raises the concerns of trust in its answers. Yeah, LLMs are not giving a reliable data because LLMs are not databases of knowledge. It is text generated based on probabilities, hence sometimes not reliable. So, in order to overcome these major limitations, two of the major limitations, we use RAG. The first one, retrieval, search for the relevant data. The second one is the augmented. The A stands for augmented, add the data as a context to prompt. Third is the G generation. Use the augmented prompt within a LLM for generating the new information. That is why we call it a retrieval augmented generation. Now let us see the architecture. The first and foremost thing in the architecture is the data. So the data need not to be only the PDF files. It may be a CSV file, it may be a text file, or it may be a URLs, or it may be the real-time data. These data, we are going to pre-process it. When I say the pre-processing, we are going to inject the data. It contains a lot of steps like data loaders. We are loading the data. Then we are cleaning up the garbage from the files. Then data tagging, document tagging, like a time, context keywords. Then comes the document duplicates. If there is any duplicate, we need to avoid these duplicates. Then document chunking. The word chunking means splitting large data document into smaller files. Then data or the document storage. So the pre-processed data will be fed into the embedding model. So when I say the embedding model, uh, it is a vector. It is a mathematical representation of a word in numbers. So these are used to identify similarities between the words or phrases. For example, when I gave who won the gold medal in the Olympics 2024, so this is a sentence. So this has got a lot of words, and these words will be converted to a vectors, that is the converted to the a numerical representation, and that will be stored in your vector database. So when I say the vector database, there are so many vector databases available in the market, like a Pinecone, Chroma, Postgres PG Vector, Elasticsearch. So there the data will be pre-processed and that will be converted to the vectors and that will be fed into the vector database. Similarly, the user query, I'm giving the query and that will also be converted to the embedding model and that will be stored in the vector database. So in my database, in the vector database, it has got both the query as well the context of the query, and that will be given to the prompt, and prompt is talking to the LLM. So when I say the LLM, it need not to be only the OpenAI. You can use op, any type of LLMs like OpenAI, Gemini, Llama. So all these LLMs you can give it, and that will be giving us a final output. So this final output will be more relevant to my query. We may not expect fake or irrelevant output. It provides access to the external or the latest data and prevent to hallucinate the data. So this is the base model of the architecture of the RAG. If you want to extend for more complex workflows, we can extend. For example, I have real-time data. I can still extend this one. I have very sensitive data with the guardrails. We can also extend for the decentralized RAG. So to the LLM, we are giving both the context and the query, and we are getting a relevant data. Hope you got a good now information about the architecture of the RAG. Thank you so much for watching this video. Have a great day.